Hello team, this is Mr. Dharma. I'm just testing that I am live. Not sure you can see me, so can you please just let me know if this is working? Okay, perfect. I feel as though this is working. Just comment in the chat if you can see me. Perfect. See the whiteboard. Awesome. So today in differentiation, I wanted to talk about a few really important ideas that we've done before. And these ideas are the ideas of tangents and normals. Okay, first off, I'm going to do this pictorially, and then we're going to have a discussion as to what this means algebraically. Okay, so suppose I give you a curve. At any given point, we can draw a tangent, so a line that has the same gradient. So a tangent has the same gradient as the point at that line. Okay? So that is a tangent line through that point. Hey Harry, hey Jackson, hey Max, hey Beatrice. Nice to see you all. Alright, so that is called a tangent line. Okay, and that's really important. So this red line has the same gradient as this black curve at that red dot. And that's all it is. It's really nothing too complicated. I can draw tangent lines elsewhere. So let me draw another function. And so I'm going to do a tangent line up here at this red dot. And that red dot is going to have a tangent line, which is horizontal. Okay. So let's get a ruler. And so this is another tangent line. It goes straight across. It tells me what the slope is at that point. But also it is a line that has that same slope. Okay, and that's what I think is really important. Now, how does this relate to differentiation? Well, if I have f of x as a function, then f dash of x is a function of its gradient, or a gradient. I'm going to use a capital G here because I don't know. I really like a capital G. Gradient function. So any x value I plug in into f of x will tell me the value of that function. If any x value I plug into f of x, f dash of x, it will tell me the gradient of that function at that point. And that's really cool. And so if I use this gradient and find an equation, equation of a line, then we can get a tangent line. A tangent line is a line that goes through that point and has the same gradient. A tangent line of a point on a function of a point. I'm going to just add some, I'm going to call it of a point x1, y1 on a function f of x has a gradient f dashed of x1 and goes through x1, y1. Okay? What that means is, this picture here, if this is x1, y1, the slope of this line is f prime of x1, right? It's the gradient at that point, okay? And we learned this in level 2. So let's try something. Suppose f of x is equal to x squared. Okay, if f of x is equal to x squared, find the gradient when x is 2. All right, how do I do this? Well, I differentiate 2x, and so now I want f dash of 2, which is 2 times 2, because I've replaced x with 2. And so my gradient is 4. So if I rough sketch that for you, if I have a function f of x is x squared, let me just... Okay, I know it's not the world's best drawing, but at this point 2, the gradient is 4. Does that make sense? If so, can you just type in the chat telling me that it does? That'd be awesome. Thank you, team. Now, what I'm going to do is I'm going to introduce you to a cool equation. The equation of a tangent line. Okay. If f of x is a function, once again, thanks guys, that's really, really helpful. Then the equation, I don't know what's happening, it's equation of a tangent line through a point. Sorry, that doesn't look right. Spell that again. Alright, this is not going to let me erase. How great. Point x1, y1 is given by okay, are you ready? Y minus y1 equals mx minus x1. Okay, this is a very, very important equation for us. Some of you may have seen this in coordinate geometry in level 2. Others of you might recall an equation very similar, y equals mx plus c. This is the better version of that. Mx plus c gives us something, but we don't really want to use it. I'd rather use this equation. Y minus y1 where equals x equals mx minus x1. Really key important information now. Where m, oh no, let's start with where y1 is equal to f of x1. So whatever the function's value is at x1, so sometimes we're not given y1, and m is f prime of x1. Whatever the x1 value is, that's what the gradient is. And we use m for gradient. Okay? M is gradient because of the French. If you want to look it up, go look it up. I think it's a great exercise for you. So that is the equation of a tangent line through a point x1, y1. Let's try it out. Find the equation of the tangent line for f of x equals x squared when x is equal to 3. Okay? So first off, let's see what we have. We write our equation. Y minus y1 equals mx minus x1. And let's list out all our unknowns. Okay, first off, x1 is equal to 3. Do we know y1? No, in this question I haven't given you y1. I'm just going to make this equal sign a little bit nicer. In this equation I haven't given you y1. But we know that y1 from up here is equal to f of 3. Because that's f of x1. And so what's f of x1? Sorry, my phone just went off. F of x1, so this is 3 squared, so that is 9. So x1 is 3, y1 is 9. What about m? M is going to be the derivative of 3. So first off, we need to go find the derivative. So let's go do that over here. F dash of x. I'm not going to show you how to do that. You guys should. It's 2x. And so here we have 2 times 3, which is 6. Okay? 1 unknown, 2 unknowns, 3 unknowns. Let's plug them in and see what we get. Y minus y1, which is 9, equals m, which is 6, x minus x1, which is 3. This is my equation. Some of you might want to expand and simplify. But for me, it doesn't matter. I'm quite happy here or here. Okay? Now, can you just tell me if that makes sense to you and you're happy with that idea? If so, I will continue. If not, I will just ask some questions or answer some questions here. But that's the equation of a tangent through any point. If I know y1, then I don't have to find it. But if I don't know it, I just plug it into the original equation. M is the gradient, and x1 is the x value that we're typically given. Okay. Now, no one's really asked me a question yet, but we'll just wait. Okay, perfect. Cool. I'm going to take the not asking questions as indication that we should try something interesting new. All right. So, what is What is a normal line? We know what a tangent line is, but what is a normal line? Alright, so I'm going to take my diagram from above, because I really, really like this diagram. I think it did a great job. So I'm going to paste this down here. Here we go. Oh, look at that. Would you look at that? It's just a work of art. Maybe I should become an art teacher, guys. So, I have this point. I'm going to get rid of the words here. But I'm going to... No, I'm not. I'm going to just erase this point. You know it's x1, y1, but I'm going to try and draw another point. Okay, so we're going to just call that x1, y1. I'm going to write it down here. Ooh. That point is really important. But now I'm going to draw another line. And I'm going to draw this line perpendicular to the tangent line. And I'm going to go through. Alright, get the ruler. And how do I know it's perpendicular? We have 90 degrees in here. Alright. Now, this thing here is called a normal line. A line that goes through a point perpendicular to the gradient. So let's define that. A normal line is a line that goes through a point x1, y1 perpendicular to gradient at that point. Meaning it has to be 90 degrees. And we know what perpendicular means. Right? And so you're like, okay, that's cool. How do we find the gradient? Well, before we do, let's write out the definition of the line. So, equation of the normal line. The equation of a normal line. I should really try a little harder for the E. Okay, the equation of a normal line. Alright, here we go. The equation for a normal line, everything else is the same, but y minus y1 equals in x minus x1. So it's actually the same equation, right? But where y1 is equal to f of x1, that doesn't change, but n is equal to negative 1 over m, or the negative reciprocal. So negative reciprocal. If this was a fraction, you'd flip the fraction upside down and change the sign. But that's what that is. Sometimes, note, Some books use n equals m with that symbol. That is the perpendicular gradient. So it's the gradient, and this is the perpendicular symbol. Either which way, I don't mind how you write it. I use n. I quite like n. But some people also, instead of n, use -1 over f dash of x1. Either which way, it should make sense to you. But the question doesn't change much. Like, what you're doing doesn't change. So if I asked you, suppose f of x is equal to x squared, find the normal line when x equals 3. If that's the question, then let's go try find the answer. First off, we try to write the equation. Y minus y1 equals n x minus x1. So we'll write out what x1 is. x1 is 3. y1 is f of x1, which is f of 3, which is 3 squared, which is 9. And then n, in this case, is -1 over m, which is -1 over the derivative at x1. And so that's the derivative at 3. So first off, we're going to go find the derivative. If you differentiate this, you get 2x. And so this is -1 over 2 times 3. So that's -1/6. Okay? So the equation is y minus y1 -1/6 x minus x1. And so this goes to what I was saying the other day. Don't unnecessarily simplify. Okay, I'm going to actually leave this answer like this because I think it's actually quite nice. Some of you might want to write it as y equals -1/6. X minus 3 plus 9. That's fine. But for me, I don't need to expand and write it as fractions because it's still just as useful to me like this. Okay, guys. So if this all makes sense to you, please tell me so in the comment. And so if you could summarize for me what a normal is and what a tangent is, and what's the relationship between a normal and a tangent. Okay. Once again, I'm going to draw this picture. Okay. I'm going to take this. So whilst I draw this, I want you to tell me the relationship between a normal and a tangent in the comments so I know who's listening. Okay? If this is a normal line, and this is a tangent line, we have a very special, interesting relationship. If we have m and n, and n is equal to -1 over m, there's this really cool thing where m times n is equal to -1. Tangent is a line that touches a single point on a line, a normal line that goes through the same point perpendicular to the tangent. Outstanding. Fantastic, Jackson. 10 points. Right, come and see me on Monday, and if no, I can't give you chocolate because it's coronavirus, but I'll commend you. So here, this relationship of two things multiplying together to give you -1 is really important, because if two gradients multiply together to get -1, I'm going to write that. If two gradients multiply together to give -1, then the two lines are perpendicular to each other. Right? So if two lines multiply, their gradients multiply together. Okay, let's read some of these. Max, a normal line is a line that goes through. Outstanding. Cool. Why is it a sad face? Tangential line that touches a single point and is the same gradient as a gradient of the function. Okay. Okay. So it's really important that you notice this relationship between these two. Okay? So a tangent line and a normal line are really important for a point, but any two lines, if you're walking down the street and you run into a line and you run into another line and their gradients multiply to -1, then those lines are perpendicular. And that's really, really cool. And that's what's really important about tangent lines and normal lines. Now, I've harped on about this for about 27 minutes. I want to give you a couple of questions. But I'm going to change it up a little bit because I'm going to give you a few questions where the functions are not just quadratics. So try this. Okay? Try these out and I'll go over them soon. No, that's not what I wanted to do. Very much not what I wanted to do. Okay, here we go. Find the following. Okay, here we go. These are tangent lines. X equals 0. Through x equals 0 of f of x equals sine of x. Not bad. Oh, right. I could post it to him. I'll see him on Monday, but I don't know. I'll sanitize the chocolate and give it to him. Okay, question 1. Tangent line through that of. This of needs some help, guys. Okay. 2. Normal line through x equals 1 of e to the x. You could give me that. That's not too horrendous task. Okay. And then question 3. Tangent and normal lines through x equals pi on 4. No, I won't make that hard. I'll make it x equals pi on 2. Am I feeling mean? Yes. pi on 2 of f of x equals cosine of x. Right? And question 4 is if f of x is equal to e to the 2x squared, find the tangent and normal line through x equals 1. Okay? That, I think, should be a fair ask. So I'm going to give you 4 minutes for question 1. If you know the equation, type it in the comments. If you don't, we'll wait. Question 2, I will go through soon. Okay, take a couple of minutes and then we'll work through each of these questions. All right. What I'm going to do is I'm going to just mute my mic for a couple of seconds and then I'll be back with you. Okay, so give these a go. Thank you, team. All right. So what I'm going to do is I'm going to give these a go and we'll see what happens. Now, I've used trig functions and exponentials because these are things I expect you to be able to differentiate. So let's give these somewhat of a go. All right. Now, I feel as though if I move them, you're gonna not be able to see the rest of the questions. Okay. But I'm going to do the first one down here. Question 1. Tangent line. I'm going to do it in blue. Tangent line. So y minus y1 equals mx minus x1. Right? So when we know that x1 is equal to 0, y1 is sine of 0, and sine of 0 is also 0. So I'm being quite nice. But what is m? M is f dash of x1, which is f dash of 0, which is cosine of 0. Okay, because I'm assuming you know the derivative of sine is cosine. So what is cosine of 0? That is 1. So if I plug that all in, I'll get the equation y minus 0 is 1x minus 0. And if I simplify it, I get y equals x. And I think that's pretty nice. All right. Now, did that make sense to y'all? If so, why should question 2 be any harder? So, sorry if you can't see question 3. Question 2, let's go. What do we got? It's a normal line. So, we go y minus y1 equals nx minus x1. And once again, we list off x1 is equal to 1, y1 is equal to e to the 1, which is e, and then m Oh, not m, n. N is equal to -1 divided by m, or -1 divided by f dash. And right over here. -1 divided by f dashed of 1. And so what is the derivative of exponential? That is an exponential, so it's -1 over e to the 1. So that's 1 over e. Okay. So what's my equation? I finally get y minus e equals -1 over e x minus 1. Right? Do I want to do any simplifying? No. Alright, I'm going to actually leave that there because I think the other two questions are quite nice for you to do. I don't want to go over them, and I don't want to make this video any longer. If you would like me to go over them, sound off in the comments. Otherwise, I'm going to leave that video there. Now you know how to find the equations of tangents and the equations of normals. Right? I'll just wait and let me know if you'd like me to go over them. But I think I am done. I think it's okay. I think you will figure it out. I'm going to just put this up for you guys to see these questions if you'd like to give them a go. Alright, based on the non-response there, I'm going to take it as, that's good, sir. We'll be fine managing these questions. Alright, team? Well, have a wonderful rest of the day. I'm looking forward to seeing many of you back at school. Thank you for paying attention. See you later.